Hello everyone, welcome back to the channel. Today we are diving with the over next part of the previous notebook, that is your iris dataset. In the previous video, you have learned about the data analysis, right? We have discussed about the important and simple terms in a live sessions about the statistics, about the machine learning. And I have shared with you in the previous video the coding part of the iris dataset, how you can perform the data analysis. So this is the second part of that video. Um, and today you are going to learn about your first model, that is machine learning model. Again, I will say, don't feel stressed. Don't think so much. Just take a broader or big picture idea about the machine learning. I hope till so far, if you have watched my videos, now you got idea what is machine learning, different type of machine learning, and how you can implement it practically. Right now, I'm not taking a deep dive just because my goal is in the first week just to make comfortable you and to help you to understand the broader picture about the machine learning. Okay. In the upcoming sessions or in the live sessions, we will take a one more step ahead with the intermediate knowledge. Okay, then we will start with the different algorithms, some complex data sets, and this is the way how we will move on. Okay, so now look at this one here, your first model building. Remember, like you did the data analysis steps. If you remember, just write down the data analysis steps in under the comment box. First, you load the data set, then you check the duplicates, missing value. You explore the data by using describe function, info function, statistics, right? You draw the graphs according to the data sites. You bring out some useful insights from it. Okay. So the next part is your this one. Here you can see first your when you start building your model, when your data is clean. Okay, when you reach at this step, it takes a lot of efforts actually. This data set was very simple. So I took this data purposely so you don't feel stressed and you can understand the steps of the machine learning life cycle. This was only my goal. But moving ahead, it will be little going to be complicated. But don't worry, I will like help you to understand each and every step in detail. Okay? So here, this is your first model building. Prepare the data formatting. Before this, your data should be clean. There should be a no your missing value, junk values, duplicates, anything. Okay, it should be completely clean. Now it is saying you separate feature X and target. So we will talk about the train and test split in detail as well. But just for now, for your understanding, just first understand why we are doing this. Okay. So you have this iris data set, right? You have this much, let's say, features. Okay. Oh, okay. I will draw it. Okay. Sorry about that. So we have this one. So this was the species target, right? 0, 1, 2, 0, 1, something like that, right? Virginica, Stosa. We have a three classes, right? So these were the features. I'm just writing x1, x2. Okay, don't worry about that. Now, if I'm saying you draw species and target, separate feature x and y. So I'm going to separate this section. I'm going to make this target section separate. This is denoted in machine learning world by y. You can keep it small or big, choice as your. Okay, there is a no harm. And this is your X feature. This is called input features too. This is we need to do. This is the most important step when we prepare the data for modeling and we call it. Okay. So what I will do, this is your whole data set, right? Now I will drop from this whole data set the target and I will separate the input feature and target. Okay. So there were the species by default target. If you remember, target we have created with the your numeric value 0, 1, 2. So I am going to delete it both. Axis is equal to 1 means we are deleting this column actually. So this denote as a axis is equals to 1. Okay. And then y is equals to this. Now, if you want to print it, you can see when we run this one. Here we go. Now print x. Now there is a no target. Okay. It is removed. And now if you want to take a look for the y, you can also take a look. I think we took it small. Okay, see, this is all your target. Okay. And instead of species, if you want, you can also keep the target to there is a no. Okay. But might be you are thinking, do we need to, as I told you previously, you need to convert your all data into numerical form. But even if you don't convert your target into numeric, your model will automatically do it. Okay. But if you want, we can choose here target to make it more convenient something. Okay. This because I don't want to give any this name, so we can keep this. This is easy. Okay. That's why we did it. Now, train test split. This is the most important function to apply on your X and Y features for the train and test split. Okay. Just take a broad idea again because we are going to do learn this again in the live session in detail. Okay. So here you can see I'm using the sklearn library, this one. sklearn is the most popular library belong to your machine learning. Without this, we can't build anymore. Okay. We will import train and test split from this. It will help in three things. Number one, it will divide your the train and test into train and test data, train data using which you are going to train your model, test data using which you are going to predict the model or going to do the predictions. Okay, we are going to test it. Okay, so we will separate the data. It will be something like this. Let's say this one. So let's say if you have 100 records, 80 records you keep for training. This is when you apply the model. You will fit the model only on the training data, okay? Here will be the 20 records. This is for testing, for prediction, okay? So here I'm using X and Y. Remember we did it. That's why we were splitting the data into X and Y because your train test is split. Take X and Y input as a parameter. Test size is 0.2. This means 20% of the data you are going to keep for testing. You can increase and decrease. This is your choice, but minimum by default in library, I think it come up with the 25 now. Okay. But you can keep it according to your choice. Okay. It totally depend upon the circumstances and different scenarios. Okay. But most common, this is the one. Okay. And then random state is equals to 42. This is actually magic number, but there is a no specific logic behind using this 42 number. You can use any number. You can use 10. You can use 100. This 42 number is taken from the Hitchcock's guide. It was from the developer who was invented the coding or something. You can read the article about it. I don't remember completely, but this is the popular one from Hitchcock's guide. Okay. All right. So the purpose of using random state means what it does, why we use it. If you don't use it, every time, whenever you are running this cell, it is going to be shuffle the train and test different records and in different orders, and your output will be different, which we don't want. Okay, so that's why we will use a random state. Random state is not going to lock your the shuffling. It will shuffle the the records, train and test, but it keep the same records. So your output will remain always same, even you run this cell many times. You can check it by running this cell with random state or without random state too, and you can print the values. Okay, so this is the purpose of random state. Okay, this is important actually. Okay, and now here. Sorry. Uh, Sorry about that. All right. Now we have split the data. Here you need to take the four variable X train, X test, Y train, Y test. Test is for your testing data. Train is for to train your model. These are the common names and we always use these. But if you use a different name, there is a no harm. But professional practice and good practice is to use this one. Okay. Choose a machine learning model. I have chosen the logistic regression because it's a classification problem and this is the like the easy one, logistic regression, and this is the most common we use algorithm. There are a more algorithm exist for the classification, but today this is your first machine learning model, so we will focus on it. Okay. sklearn underscore linear model because it comes under the linear model. Okay. Model is equals to logistic regression, maximum iteration is equals to 200. This means your model is going to build the relationship and check the patterns of the data by iterating maximum 200 times. Okay. So it doesn't mean if you have, like I mentioned here, 200, it is going to be run your model, build the relationship using 200 iterations. It can be less than that. It can be 20, 30, 40, 100. Whenever it got the good predictions, like most good results, it will stop the model. Okay. So this is the purpose of logistic regression, and logistic regression will predict or classify the output for the classification problem with the help of sigmoid function. Okay, I will explain this function in detail when we will work with the logistic regression in the upcoming like the video, or we will like take another classification. Okay, so here I have keep the model name model. You can keep any name. You can keep it iris underscore model too. This is your choice. Okay. After that, the next step is you will train the model. Now it's a big step actually. Okay. Train the model. Model dot fit x underscore train comma y under. Did you notice? We did not pass any test variable here because we never ever fit the model on test data. Otherwise, what will happen? There will be the data leak. If you will fit the model on the test data too, when you will like take the test from the model for the prediction, it knows all answers, right? So I will give you the layman example here. If you are my student, I am giving you the question and answer. Just go through it, right? You are just learning from the content, like from this notebook, right? I'm giving you the problem too. I'm giving you the solution too. And but I am hiding the test portion from you. Okay. I'm not telling you like what questions will come in the test, but they will come from this test only, like from this content only. Okay. So I am hiding the test portion from it. So when you like split the data using the train and test split, you hide that 20 records under the test variable and you are not going to fit it. Okay, you are going to use it for the prediction. So this is the major difference. It is going to fit here. It will take the like the mean of the data. It will do this. Okay, uh, it is going to calculate your mean values of each feature, minimum value, maximum value. You might be thinking, what is this? This is the all functionality of it. Okay, I will give you the example. Look at this one. So this is your target 0, 1, 2, right? So here is the values of sepal length, sepal width. There is some value 2, 3, 4, 5, 6, 7. Or you can take any value. This is the junk value. Okay. So what the fit will do? It will check the minimum value of this feature, maximum value of this feature, and also check the average. Same with this one and same with this. Then it will build up the relationship and predict. This is the way how it work at the back, the fit map. Okay. This is the purpose of this one. So this is again broad picture. And then make a prediction C. We will use y underscore predict variable here. Model dot predict C. I have used the x underscore. Okay. So this is the x underscore test. We are not going to use here y underscore test. Why? Because we are going to check the predicted value against the test predicted values, right? That the answers we already know. Like for example, if I'm giving you some questions in the test, right? So I'm hiding the answer from you. I'm giving you the questions now, and you are writing the answer here. This means that, okay, as a layman. And then I will match your answer with my Y test, with my answers. Okay. So now here we go. So here you will predict. If you want, you can type this too. Let me show you how it will look like. So you can type this one by, um, here we go. Uh, here we go. Okay. So it will look like this. See, I think I need to run. Here is this one. Because we changed the value, right? So this is showing in the same, whatever target we have kept, right? So now we will check the accuracy. This is called evaluate the model performance, how model is working. For this, I'm using the simplest one, accuracy score. There is a one more confusion matrix, but I will introduce you in detail because it's a big topic again. So here accuracy, we will use accuracy underscore score. This is the inbuilt formula for this. See, here we have passed the y test. This is my answer. Okay. And this is your answer. You have written for the question I have given you in the test. This is your answer. Now I'm matching your answer with my answer. So if your all answers are matching with my answer, then you got 100 marks. This is same with the model. Okay. And now this is a confusion matrix. This is the most popular evaluation matrix or performance check of the model for the classification problem. Okay. For this, sklearn matrices import confusion matrix. So we will generate this method, y test, y prediction. Look at this. We always read it diagonally actually. Okay. Here, let me open this. We always read it like this, diagonal. So it is here will be the your actual values. Here will be the predicted. If actual value is equal to predicted value, then this is means correct. So 10 will be your correct. There is a no other value because there is a no 1, 2 something. So these values apart from diagonal, these are the false prediction, wrong prediction. This is correct prediction. Okay. So I have draw the graph too, so you will have the better understanding about it. Let me scroll down. Look at this. See, this is your predicted, this is your actual. So if you have given the input feature, right, to the model and your model 10 feature, like the inputs, your model is saying, yes, this is Setosa. So you have given the y underscore predict and I am checking against the y test. So this means this is correct answer. There is a no wrong answer. Same with the your versicular predicted is versicular 9, 9 input 9 is correct. Your machine is also predicted correct. Same with the Virginica. So this is the way how your confusion matrix gives you the very clear vision about the correct values. Okay, but it is based on the false positive, false negative, true positive, true negative. But this is not the right time to discuss it in detail because we need a separate session for this. Okay. Just take a broader picture again, I will say. Okay. So this is the model interpretation. This is the optional part. This is not your mandatory part. So here I'm just converting it into the data frame and I'm showing you the coefficient values. Coefficient values means what values your model has used at the back end during the prediction. If you look at this, Setosa, this is your target. And if you look at this one, let me change. Huh? So if you look at this one, this is minus 0.39. This is very less value. Out of all these values, right? This one is the biggest one. So this one, this means your setosa, when petal length is there, right, higher, then it is able to predict your setosa flower. Okay. And versicular, here you can see, although it is a negative correlation, but this is higher, right? And here is a petal width too. 0.9. This is negative correlated, but 100% negative, right? So this is showing the coefficient values too. If one is increasing, others decreasing. Remember, we did it in the data analysis too. And when you look at the versicolor, okay, so it is the sepal length 50%, right? Very strong relation, positive, based on the sepal length. Virginica, look at this, 2.5, 1.77, strong positive correlation, right? So this means this is the coefficient value. It is used to predict Virginica. So it was easy for your model to separate the Virginica from setosa to versicolor, and it is telling you what is the maximum like the feature used with the coefficient value to do the prediction of the targets. Okay, so this is the purpose of this one. This is optional, but this is just for your learning to look at the coefficient values. Okay, so might be you are thinking from where these coefficient values are coming up. This is your model automatically decide. Okay, when I will explain you the mathematical part about it, so you it will make more sense to you. Okay, and then we have a final prediction. This is just I was just checking the how many columns to make sure. Here I have taken the dummy values. Okay, this is the new test data which does not exist in your data set. Okay, so I have taken the sample flower value, sepal width, sepal length, petal width, petal length, this one, right? Four features, and then model is predicting. So model is predicting if these are the input features. So this kind of features create a setosa type. Okay, so this is a completely new data. This is the way how it will work when your model is ready. You have deployed in the market, and new customer is coming. They are entering the detail, and your model is giving you the output. This is at the backend level. This will not be the actual picture of the deployment. Deployment look like different. In the deployment, there will be the HTML page, and you will make something like this. You will create the front end page like this, and you will say enter petal length. Here will be the text box, petal width. Here will be the text box, sepal width, sepal length, something like this. So if I'm the new user to your this, so you will enter 5.1, 3.1. I will enter, sorry, 1.4, 0.2. And it will tell me this is the features of Cytosol. This is how it look like after the deployment. This is just backend. We are doing it through the, okay. So this was all about your model building. So now if we repeat, so how the machine learning works. So you start with the, I will repeat, let me make it this. We start with the problem definition, right? Load the data, then explore the data. What you have done in the exploration? Duplicates, missing value, describe, info, right? You are trying to understand the data heat map, checking the correlation. Fourth, explanatory, where you are taking the action on the data. If there is a spelling mistake, please ignore it, okay? And then modeling part. So you split the data, declare the model, fit the model, predict the model, right? And what you have done after that? After that, sorry, it won't be scrollable. After that, you are doing evaluate the model, right? And then you have did the testing using the new data, testing with new data. So these are the simple steps. These are the steps you are going to perform in each on each and every data set. Either it's a complex data set or a simple data set or very complex data set. Okay, so these are the steps. This is for the specifically supervised machine learning. Okay. There might be some functions we applied during these one according to the data set, but main steps will remain same. Okay. If you have any question, you feel free to ask the question, post your comments, okay? And you can download this notebook and work on this and see you in the next lesson. And I will conduct the live session for the next video first. So we will discuss about the theoretical concepts again, which is important for that coding part. And then we will jump onto the coding part again. Okay? So see you in the next video. Thank you so much for watching this video. And if you are new to my channel, don't forget to subscribe my channel. Enjoy the course, become expert. This is the goal of the science data science. So much.